Okay, the last section of this unit, and we have done circle trig. This will be the full completion of all major circle trig. Then we go off and do other things after that, for sure, other kinds of trig. But let's see if you know what you're supposed to know so far before we get into introducing what secant, cosecant, and cotangent are. Let's just do a simple one. Let's go with negative pi over 4. Would you please find the sine of negative pi over 4? I'm going to pause for a second while you give that one a try. Okay, so here is where negative pi over 4 would be. You go this direction, and pi over 4 is 1/4 of the way to pi, right? So negative pi over 4 is 1/4 of the way there, which if you go by degrees would be like a 45-degree angle, and therefore I like to think of this as a 1/1√2 triangle. Now I know some of you have gotten into the whole unit circle thing, which means you'd want to divide by √2. You don't have to do that though. In my opinion, it just makes it more complicated during the middle of a problem like this. If you've got it memorized though, so you can just go, oh, I know this one, this comma this, great. Then you've got an advantage over everybody else. That's awesome. All right, now, it won't work for everything, though. We're going to practice that in a minute. 1/1√2, negative is right there. Easy to forget that negative. And then the final answer, sine is opposite over hypotenuse. Does the negative matter? Oh, yes, it does. -1/√2. Raise your hand if you had that one right. Or the 2√2, which would be the same. √2 over 2, which would be the same thing. Okay, all right, good. So now, what happens if it's weirder? Like, what if it happens if it's at a spot where you can't draw a triangle? Like, for instance, negative pi over 2. Now you got to change gears. You can't do opposite over hypotenuse, but you got to remember that sine is which letter? Y. Cosine is which one? And then tangent is? That was really weak. Let's do it one more time. Sine is? Cosine is? Tangent is? All right, there you go. So find sine, which is y, at that spot. So this is the kind where you do need the unit circle. You do need that spot right there. Is that where you figured out was negative pi over 2? Down there, okay. And you do need to know what that spot is. Well, don't think too hard. It's just a circle with a radius of 1, and you're on the spot where the radius would go right there, you know. So you know it's at 0, comma what? -1. And the sine is the y of that, so therefore it is -1. Okay. Next up, I think I want to go back and touch the kind where you don't have it on the unit circle. You could not get it from the unit circle. Sine of some angle is -3/4. It's not on the unit circle, but you got to be able to draw a triangle for that. Okay, so everybody try to figure out where sine is negative. I'll give you that hint. ASTC kind of helps these. And now, for right now, all you know is you got to draw a triangle. Then you're going to figure out what that triangle looks like. And if you get it drawn in the right spot with the right sides, these are easy. Because then you just got to find cosine of it. Point. I don't care what the angle is. I just want to know what cosine of it is. So try to draw that triangle in the right spot. All right, I'm going to pause for a second while you work on that one. I hope you found that sine was negative, and therefore it couldn't be here, and it couldn't be there, because those are the places where sine is positive. Did you realize you were supposed to draw something here and here? And I try to make the triangles kind of ambiguous. Like, if I make the triangle long and skinny, then it's only going to work if it happens to be a 30-degree angle right there. You see what I mean? Because I don't know, when I first am looking at it, I don't know how big the angles are at all. So I encourage you to always make your triangle kind of like a 45-ish. That way, if I put a 60 in there, you're not going to go like, oh, that's impossible. You know what I mean? Like you make it a little bit short and fat triangle. That way you can put in any angle you want and it'll look okay. All right, so there, I got my triangle drawn, one at a time. Now I'm going to look at the sine opposite hypotenuse. Do you know that third side? We practiced those. You remember how we did square roots? And then we did 16 and 9, and the only question then was whether we should add them or subtract them. On this kind, you should subtract, because on the big side, you'd want to add them. All right, there. Oh, sorry, minus. So then this one's the square root of 7. What's wrong? There you go. So easy to forget that negative. All right, good. Now I got that. Now it's just time to do cosine. Cosines that over that. Negative root 7 over 4. Raise your hand if you had that one right. All right. Notice how the unit circle didn't help a darn bit. Okay, and the point is you can still do circle trig without the unit circle. Yes? Oh, thank you. There is another answer. Just clarify. If I wanted what are the angles, there would be another answer. Oh, boy. Okay. Yeah, I get what you're saying. And I should have, on a test, there would have been something else. They would have said, oh, by the way, you're in quadrant 3. Because otherwise, there'd be 2 angles. Typically, we don't do this other one on this kind of question. We will say, oh, and the reason that you're in quadrant 3 is that tangent needs to be positive. I should have thrown in one more little thing like that. Is greater than 0, and therefore, if tangent's greater than 0, I can't be here. Anyway, on that kind, there's usually only one answer. Let's do one where there is 2 answers to show you what I mean. This would be the kind that you know the sides and stuff. All right, sine of some angle I don't know is negative root 3 over 2. That one's got 2 answers. It's different because I know the sides, and therefore I can find the angle. And as soon as I got the angle, I can get a different angle. The one we did a second ago, I never asked you what the angle was. I asked you for sine of the angle or cosine of the angle. On this kind, I'm asking for the angle, and there's 2 of them. Figure out which side's negative. Draw your triangle. Put in your sides. Pause for a second. I'll give this a try. Okay, in the back corner, CA. Tell me how to start. So when the ASTC world, what ones should I cross off? Yes, these are out because sine's negative. I like it. And then one at a time, let's draw a triangle in here. Now tell me what to label for these sides and the important angle. Now you could say things like opposite and adjacent. Okay, opposite side is negative square root of 3. I like it. Keep going. All right. And what's the other side? Do you know this one? All right. And you could have got it with that other strategy. That's not. Oh, negative 1. Oh, it's so easy to forget the negative. Okay. All right. Now what? Did I want to like find the sine, cosine, or tangent? No. I wanted to know what the angle was. So what's the angle? And you're like, oh, that's a 60-degree angle. Don't say 60, though. What's the answer? Okay, let's do it right now. Would you agree it's more than 180 because it's down here? So 180 plus 60. 240. What if you wanted to count by radians? Well, then it'd be 4 something. 4 pi over 3s. 4 60s. 4 pi over 3. Yes. Yeah, we're not done yet. We just got our first answer, which is 4 pi over 3, or what did we say that was in degrees? 2 something, 240? All right. All right. Remember how there's 2 answers? That's the same answer, but in radians and degrees. Okay. Mr. RS, tell me what to do next. Yep. I'll draw in the triangle. You tell me what to do with it. I'm trying to be psychic of where you would have put that. All right. All right, good. Give me some angles. All that really matters is that angle. So there's the final answer, 60 degrees? No. Yeah, you got it. And if you can't do that in your head, I'll show you what he was doing. He was going from here all the way around, and he went 360, I could tell, and then he subtracted off the 60, and that made 300. Okay? Or, if you don't want to do 300, if you want to instead do radians, you could say 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Or, if you wanted to multiply it by pi over 180, that would have worked. And that way the degrees would have canceled, and you could have reduced 300 over 180, and it would have been 5 over 3. That's a way to get the 5 pi over 3. But 5 pi over 3, and the other one was 4 pi over 3, and there's your two answers. Yes? It will say whether you want it wants degrees or radians. And I can tell you this, I don't think I have ever marked one wrong because the kid used radians. It's almost always the other way around. If they're going to force you to use something, they're going to force you to use radians. So err on the side of using radians, because I think I can even make that commitment, except for in a problem where they're asking for like, what's 5 names for this spot? Well, then you're going to have to use degrees and radians. You know what I mean? But otherwise, I can say if you use radians, I'm not going to mark it wrong. Yes? Yup. It's a good question. You do need to, if I was going to show this problem as a unit circle question, then what I would want to see out of you is that you drew the circle. Here, let me just show you the work for a unit circle person. You should have then showed that it was here and what that spot was. You know what I mean? That would be reasonable work. So like right here, do you have that memorized? What is it? What comma what? Negative 1/2, negative root 3 over 2. And then at the other spot also. So the key is you're knowing that sine is the y, and so that's your spot. And there you go. That'd be your work for that. Okay. Going to be handy to have the unit circle memorized. On Monday, I'm going to give you a very small, not high point, but quiz that's going to go in the homework category. If you've got your unit circle down, or can recreate it by drawing the right triangles for it. You know what I mean? Like, you don't really have to have it memorized. If I ask you for this spot, I'm not going to make you do the whole thing. I'm going to pick some spots. If I ask you to, like, tell me what point would be right here, that's the one that's a 45-degree angle right there. If you've got that memorized, awesome. If not, you could figure it out. Go, well, if that's really a 45, 1 root 2, negative, negative. And so what spot should be there? I can think it through. The y, or the x direction was this. The y direction was that. And one last thing, though. Wait, I'm in the unit circle. So that means the radius has to be 1. So there, I recreated it without having to have it memorized. You got it memorized? It's even easier. Okay? But I'm going to ask you for a few spots, like tell me that spot, tell me that spot, and tell me that spot, or whatever. Okay? All right. So what's new? What's new today is that there's 3 more functions. Thankfully, they are completely related to other ones. That's why cosecant, for example, is a new function. You've never seen it before. You've never heard of it before. There is no cosecant on the calculator. If you look at the calculator, it doesn't just have sine, cosine, and tangent. It's because these are just a reciprocal of each of those. So in other words, if I wanted one of these new ones, the cosecant, I don't actually find cosecant. I go and find its sister function, get that answer, and then flip it. I just have to do the reciprocal of it. All right? I think you'll understand it pretty quick. It's a pretty easy thing for today, thankfully. All right, so let's make a nice, easy one, but leave lots of room over here. We're going to have to like do a bunch of like little problems to show you which functions go together over there. All right, so here is sine, the easiest one of them all, sine of 30 degrees, and sine is opposite over hypotenuse. There we go. Yay, that's a nice, easy one. So sine of 30, leave plenty of room because we got to say its answer and then show you what its sister is, the sister function. I like to call them sister functions. Technically, they're reciprocal functions. So sine of 30 degrees, it's probably the 30th time it's come up now. I told you to memorize it a long time ago. What is it? A half. And if you just look at your triangle, it's opposite over hypotenuse. It's obviously a half. Let's do the other ones that we already know. Cosine. What's cosine of 30? Just look at the triangle. You can do it. What is it? Root 3 over 2. And then the last one is tangent. And that's TOA, opposite over adjacent, 1 over root 3. Okay. So there's what you already know how to do. And then here's the new ones. Cosecant, it's got a 3-letter abbreviation just like these. I hope you get this is actually tangent. It's a longer word. That's just short. This is cosine, S-I-N-E. Cosine is it's a lot of letters, so it's shortened to 3. That's S-I-N-E technically. Sine is pronounced and spelled S-I-N-E. And so these are just 3-letter shortcuts. So CSC is a 3-letter shortcut for cosecant. Cosecant. Have you ever heard of a secant? There is other contexts for the word secant, and I can tell you more about it later. For right now, let's just say cosecant of 30 is, and from a context of what I said before, I bet you can tell me. 2 or 2 over 1. I like 2 over 1 just a little better because it shows the kid who is a little lost what happened there. You know what I mean? 1/2 didn't turn into 2. It's like 1/2 turned into 2 over 1. It's just a flip. Okay? And if you're going to try to memorize this, the thing that I think helps is that sine and cosecant have an S and a C relationship, and the next two also do. Cosine goes with secant. SEC, 3-letter abbreviation for secant. And the secant of 30 is, you just got to flip those, 2 over root 3. Just take the answer and flip it. And again, there's an S going with a C. You get what I mean? One of the old ones that I knew, sine, cosine, tangent, the old friends. This is one of the new ones. There's only one new one that starts with an S. I know there is another one that starts with an S, but there's only one new one that starts with an S. All right, and then last but not least is cotangent. Tangent and cotangent are the only two that seem like they should go together. Tangent seems like it logically should go with cotangent. And some of you are realizing, but wait a minute, how come it isn't just sine going with cosine? Because they aren't a flip of each other. You can't, that doesn't work. It happens to be that tangent and cotangent are co-functions, you know, tangent, cotangent. They're co-functions that also are reciprocals of each other. That's weird. You'll understand it more as we progress. I'm going to try to explain everything today. All I really need to connect today is that sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. And how do you get them? They just take these, flip it. Take this, flip it. Take that, flip it. If it had been negatives, it would have still been negative. It would just been flipped. So don't think that the negative somehow goes away if you flip it. If you have, like, think of the negative as being on one of the numbers. When you flip it, it's still there. Okay. So I had a question and then it went away, but is the question still there? Anybody got a question still? Okay. All right. Then let's see if you could do this without me drawing it all out for you. So here's a typical question. What is the cosecant of 5 pi over 4? So first, I'm hoping you're realizing you got to know where 5 pi over 4 is. So draw the circle. Try to find 5 pi over 4. Then make a triangle for it. Then don't try to do cosecant. Do its sister. This is like the only time when it's totally okay for you to say, I say find cosecant, and you say, nope, I'm going to find sine. I refuse to try to find cosecant. I don't do it. I don't do that myself. I do not try to find cosecant directly. Yes, you could try to go through and memorize them all. Like you memorize sine as opposite over hypotenuse. You could try to memorize this as hypotenuse over opposite. But interestingly, I'll give you the acronym for it if you want. It comes out to Chosakao instead of Sokotoa. You got Chosakao. But unless you want to get that in your head and try to keep track of hypotenuse and opposite, hypotenuse and adjacent and opposite, the problem with this one in particular, and the reason that they don't ever push this, there's two C's. You can't tell which one's cotangent and which one's cosecant. See what I mean? So it's not, that is not a great way to do it. I made that up. It just to kind of show you that you could do it, because this one is the sister function of sine, and sine is opposite of hypotenuse. You could do it that way, but don't. Just when somebody says find cosecant, you go, okay, I'm not going to find cosecant. I'm going to find the sister, and then I'm going to flip it. All right, so let's do that. So, OC, what did you get for the cosecant? Boy, actually, don't tell me the cosecant. I hope you started here. What did you find first before you found cosecant? I like it. So these are all 45s. So what did you get? And then which one's negative? And? All right. And then what function do you actually do? You didn't do cosecant, you did sine, yes. And so sine has to be found first, and that is the opposite over to the hypotenuse. And then what do? You flip it. So final answer? Square root of 2 over -1 is the way I'm going to say it. Because that way it's just exactly upside down from what sine it would have been. Okay? So you think about sine. In fact, you could even write, I'm going to find sine of 5 pi over 4 first, and then I'm going to flip it. 1 over that makes it flip. No, you don't have to do that. You can just find sine and then flip it over in your head. Saves you a bunch of work. You don't have to show all that. But definitely don't try to find cosecant directly. Find sine, then flip. All right, let's see if that's stuck. This one's going to be weirder because it's at a quadrantal. What is the secant of pi? Pausing for a second. Let me give that a try. Okay, so you're saying I should start here. And then what? Can you draw a triangle for that? No. So what do you do? Okay, I can buy that. And then what? Do you know what spot that is? Something comma something. Correct. Then, do I really want to find secant? No. I know you're not the rebellious type, but say, no, I'm not finding that. Instead, I'm going to find good. Cosine is the what? All right. How are you going to flip that? I agree it's over 1 in the first place, so final answer? Raise your hand if you had -1. All right, awesome. Okay. One more like that. This is the kind where you're going to have to draw a triangle and put sides on it like 8 and 11 and figure out the third side. And then I'm also going to throw in the whole cotangent thing where you'd normally find tangent, but you got to flip it and all that. Okay, so here we go. Cotangent of, let me think, what haven't we done in a while? 7 pi over 6. No, I'm wrong. I apologize. I didn't do that right. That's a valid question, but it's not the kind I was trying to make. Sorry. It would work, you're right. But what I meant to do is like this. Cotangent of an angle is 7 over 8. Weird. You don't know that one. Therefore, you draw the triangle, you label its sides. Good point. Now it'll only be in one quadrant. And the actual question is not what the angle is, because you wouldn't know what the angle is because you don't have this memorized. So instead, they'd ask you, what's the sine of theta? So remember how this is the kind where you say, I'm not going to do cotangent. So instead, you're going to do what? Tangent. So let's rewrite this as a tangent. Tangent of theta is equal to what? 8 over 7. That might help some of you. You know where tangent is positive. You wouldn't have known where cotangent is positive, but you know where tangent is positive. And then you got to figure out, wait a minute, tangents, uh-oh, dang. You're right, sorry. I can't say tangent is negative. I can say sine is negative. My bad. Oops. And the final question, did I say sine of theta? Final question? Yeah. Okay. What's the sine of theta? Okay, you got to find all three sides. So I'm going to say something that I've said before. If you can get it, so you've drawn a triangle in the right place and you've labeled all its sides, then the question is easy. Pausing while you give this a shot. Okay, BDB, that'd be you. Can you tell me what quadrant I'm in? Prove it. Tell me one step at a time how you could prove. Oh, let's say there's another kid that says, no, we're here. How do you prove it? Okay. So sine of theta is less than 0, so that crosses off the top two. I agree. Awesome. But it can't be there and there. Tell me more proof. Why can't I be here? Oh, but wouldn't the negatives cancel and make it positive? Maybe we are there. How many of you drew yours in this quadrant, the T quadrant? All right. How many of you drew it in the C quadrant? I'm curious. Oh, interesting. There's different opinions on that. All right. How about this? Could you both be right? Yeah, you actually could. But you're not. Because would you agree that this right here says that tangent is positive? That red statement. If tangent is positive, can we be in the C area? No, not if tangent's positive. That's out. Okay, so now we're drawing it in this quadrant. I'll draw it, trying to make it kind of ambiguous as far as which angle's big and small. I make it kind of short and fat. I can get away with labeling it as anything then. So FK, can you tell me what to do to label these sides? So from that angle, this is the one we care about. The opposite is 8. I agree. Opposite over adjacent. You're using tangent, aren't you? We aren't even touching cotangent yet. All right. Good so far. What's the third side? Oh, question or comment? Yes? They're negative. It is easy to forget because they were both positives over there, but the negatives had canceled as well. Okay. 12-minute warning, so we're getting to the homework soon. Yes? And I could get that just to show people a 64 and 49, and since it's the long side, we add. So square root of 1 what? 113. Awesome. Okay. So the third side, square root of 113. Now, do you remember me saying if you can draw the triangle in the right spot and label it with the right sides, then the last step is easy. All I want to do is find sine. So what's sine? Opposite over hypotenuse. So opposite is negative 8. Hypotenuse is square root of 13. Negative 8 over square root of 113. How many of you had that one right? Okay, awesome. All right, you've learned 3 new functions. Let's just make sure one last time if you know which ones go with which ones. Sine goes with its sister, which is cosecant. So remember, S goes with C and C goes with S. Cosine goes with secant, and then tangent goes with cotangent. And they're just a flip of each other. All right. So if anybody asks you to find cotangent of something, don't freak out. Just say, okay, cotangent of 5 pi over 4. I'm not doing it. I'm going to go figure out tangent of 5 pi over 4, and then I'm going to flip it. Okay. All right. So now your homework. Let's get to it together. I think we determined earlier what it was. 13 point, what? 2? 13.2 day 1 or 13.3 day 1? 13 point, oh. There we go. I had a 3 in my head. I knew there was a 3 somewhere. Okay. 12.3 day 1. Okay. And there it is. Now, this is technically where the assignment begins. And honestly, those questions seem a little too easy. I hope you're feeling like, hey, that's awesome, that's too easy. But if it's not too easy for you, if you're like, I don't know if I can even do that, then you should probably do them. But I'm letting you skip them if you think you can. The test is not Monday. The test is Tuesday. So we have a whole nother day to review Monday. But if you're feeling like, oh, I'm not sure I'm ready for this test, try these. You have a key, try them and check the key. That's what I am assigning, and I apologize for it being messy, but this thing is like impossible to erase with. I don't understand. So anyway, you're doing those problems. And 117 pi, for example, some of you might be annoyed by that, but if you think about it, you start here at 0 pi, and you count by pi's. You get 1 pi puts me over here, and 2 pi would put me back here. 3 pi is here. 4 pi is there. Are you catching on to the pattern? So therefore, do you get 117 pi couldn't be back at 0? Because it would have to be even, like 2 pi, 4 pi, 6 pi, 8 pi. Okay, so an odd number of pi's has to be over here. So really, it's just tangent at that spot, which is the same thing as pi. So 117 pi is the same thing as pi. If you really want to, if you're bored, go like this. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and keep going until you get to 117. You'll probably get bored somewhere in there and go, okay, it seems like the odd ones are on the left. Okay. All right. So it's really tangent to that spot. How do you get that spot? You got to know what it is. That's at negative 1 comma 0. So then tangent is y over x, and then it's not that hard. All right. So I strongly encourage you to do all of them on this page, and then the next page, the top two. Now, I always suggest that you put these over 1 to remind yourself that there are two sides, even if there's only one number. You can always put it over 1. That way, if cotangent is something, then you can go, not doing cotangent. I'm immediately changing it to tangent, and then you can flip it. It's easier to flip if you have a denominator, okay? And then challengers, as you would expect, those are something that are very challenging, and you can do it, but you don't have to. Okay, so just those 2 pages. This is a doable amount. If you're not willing to do that, you should not be in the honors class. Really, I'm just being honest. You got to do the practice, or it's not going to work out so well on the test. Okay, so anyway, that's due on Monday. Plus, on Monday, we're going to have a very short unit circle quiz. I'm going to hand these out, and I'm going to tell you a few spots that I want to know. Like, what's this spot? What's that spot? What's this spot? That kind of thing. Okay? You can just do them all if you want to, but I'm not checking them all. I'm going to do a spot check like that, where I'm just going to pick a few spots. Okay? So don't be all stressed about it. You can make triangles to find the unit circle. So if I'm pointing to a spot that you did not memorize, like, I have to know what's here. Yeah, because you should know that's a 30-degree angle, and then you'd know everything. You should know if it's the 30, 60, 90. You should know then if that's 30, that's 1, 2, square root of 3, and then you should know that that side's negative, and therefore you should be able to recreate that spot on the unit circle. Because the y, sine is the y, sine is opposite over hypotenuse, so therefore it's 1/2, and cosine is the x, which is adjacent over hypotenuse, which is negative root 3 over 2. So there, I recreated the spot without knowing the unit circle. Okay? So it's not really about memorizing the unit circle, it's about memorizing how to do circle trade with 30, 60s, 90s. Okay, that'll happen on Monday. Very small number of points, not a big hoo-ha deal. What's a big hoo-ha deal is the test. And I know some of you, like, well, I can always retake the test. Just realize you're putting yourself in for an extra 2 hours of work and coming in the morning, like, which might involve a special car trip for mom or dad, or for you getting up early and all that stuff. Wouldn't it be just a little easier to study more the first time? Don't get into that loop of, well, I can always retake it, because then, crap, that's going to cost you 2 more hours of your life, which is going to just make your life more difficult later. So take an extra half hour, study a little more for that time, the test the first time. And that's all I have for you for today.